Hello, friends. Jim here. Here's a headline from the online publication EOS. Ocean warming is wiping out Southern California's mussel beds. Historic photographs reveal the dramatic retreat of mollusks as warmer waters take a toll on the health of the intertidal zone. And for those of you who may not be unawares, intertidal is what the name implies. It's the zone that's between high and low tides. So the organisms that live there, they need to adapt to conditions where they are covered by seawater and then exposed to the air. So they have physiological challenges. Now, what you see flashing back and forth here, and I wish there was a way to stop this, but this is like a before and after. Let's start with, 1984. Then it goes to 2023. If you look at 1984, and you might want to just stop the video at this point just so you can look at it, but when you look at the 1984, there's a couple of transect lines there, but you can see this is all mussels. And then, all mussels, and in 2023, all gone. Mussels, gone. Quite dramatic. Mussel beds along the state's southern shorelines are disappearing as climate change alters the region's ecology, according to a new analysis by aquatic ecologist Corey Garza of the University of Washington. Garza and his team compared modern and historic photos dating to the 1970s to track how mussel beds have changed in 3 locations within the Southern California Bight, a sweeping curve of coastline and islands centered around Los Angeles. And he presented the findings in a poster at the AGU's annual meeting, 2023 meeting in San Francisco. California mussels live in rocky intertidal areas from northern Mexico to Alaska. They start out as planktonic larvae in the ocean, eventually anchoring themselves to rocks, and they do so in tight clusters along the shoreline. However, rising water temperatures have made it harder for mussel larvae to thrive in the water column. Those that are able to survive are exhausted. Warmer waters also mean that fewer plankton from other species survive, so mussel larvae that do colonize the shoreline have less to eat. Okay, these are filter feeders. These filter feeders have to also contend with oceanic predators like sea stars, spiny lobsters, as well as heat stress from solar exposure during low tide. So, a couple of key points here in this paragraph. Fewer plankton, right? I've discussed with you how warmer oceans are leading to decreased productivity. Well, mussels are filter feeders and they feed on plankton. Fewer plankton, they're not going to have much to feed on. That impacts their growth rates, impacts their abilities to form gametes. So further year class strains are impacted negatively. Right? And the waters are warmer. The air is warmer, imparting further physiological stresses upon the organisms. And sea stars, they like to surround the mussel, and using their tube feet, they can create a very strong suction. They literally just rip them open and then, munch away on the inside. So the historic photographs in Garza's analysis, of which we kind of got a glimpse of at the beginning of this video, came mainly from the U.S. National Park Service archive and retired scientists. So Garza said there wasn't really any idea that 50 years from now these are going to have the record of the impact of climate change in Southern Cal. To trace that impact, Garza and his team looked at high definition drone images of the same mussel beds that were in the prior old photographs. They created 3D renderings and then basically overlapped the images and then did a comparison. The team then used mapping software to estimate how much of the tidal area was covered by mussels in the old and recent photos. And how did the boundaries of the mussel beds, how did they change over time as temperatures changed? And his analyses revealed that climate change has been affecting the mussel since at least the early 1970s. So yes, we are talking 50 years. The impact of climate change started a lot earlier than we thought in that system. Fewer food options and dangerous predators have caused the lower boundaries of mussel beds to retreat upward. Okay, the lower boundaries meaning uh, towards the low tide mark. Now, the reason why they're talking about retreating upward is to escape the predators. Starfish and the spiny lobsters have to stay submerged. So they're being stressed out there, so they're being forced further higher up in the intertidal zone, getting closer and closer to the high water mark where high tide takes place to basically evade predation. So that means, okay, they may be evading predation, but they're also not going to be grazing on phytoplankton. So as they move further up, they still have to deal with the sun and so forth. Rising ocean temperatures are changing mussel habitats throughout their range. The recession pattern could be unique to Southern California. Well, the only way to verify or refute that statement is to study other areas. In most of its distribution, exactly the opposite thing is happening, which is the lower boundary is going way lower, said marine ecologist Peter Raimondi of University of California, Santa Cruz. In some intertidal habitats, warming oceans have hurt populations of sea stars. So prey species like California mussels and other mollusks are spreading deeper into the ocean. Okay, this is interesting. So basically, the warming oceans have impacted the sea stars negatively. So the mussels, having less predation pressure on them, can actually move further into the water, lower into where it's more the low tide realm, where they can perhaps encounter or have a greater chance of encountering phytoplankton, to graze upon. So now the question becomes, what is different between these regions? Why is not impacting the sea stars in one location, but impacting in another location? What is the difference in the ocean temperatures? What are the physical processes, the mixing regimes? Right? What are the what are there any differences in the salinity? A lot of parameters that need to be measured and compared to find out what this difference is all about. And Garza himself was able to note the decline in mussel colonies in Southern California. He remembers seeing mussel beds on Catalina Island, one of the study's location, when he himself was a student some 30 years ago. He goes, now I go back with my graduate students, and there's nothing out there anymore. It's clear things have slowly receded up the shoreline. So this ties into what I have been speaking in general terms, in broad terms, but here is like a tiny snippet of an example. How the warming oceans can change the ecology, can impact the primary producers, would then have ramifications up the food chain, and how changing condition can impact, in this case, the mussels being the primary consumers. It can impact them negatively in one area, but maybe a little better in another area. But their predators, the sea stars in this case, are impacted negatively in one area, but positively in another area. Like everything else, physics drives the biology. We need to get better handle on what the difference in the physical conditions are between these two regions to understand the difference as described in this video. What I'm basically saying is you got to look at more than just temperature. What's the water chemistry? What's the physics? What's the salinity? What's the mixing regime? What's the horizontal, vertical water movement, etc., etc. But ocean warming overall is not going to be a good thing for organisms. There you have it. Until next time.